And if I scan down through here, I see that there's 1, and there's 2, and there's 3. And actually, if I look at our chart, I do see 3 outliers, 1, 2, 3. So let's begin to remove those and notice what happens to our chart. So the very first year that's recorded, I'm going to select that cell, and notice I'm highlighted over on row 2. And let me slide over so I can see the plot a little better. So I'm going to select the entire row. I need to select the entire row and move the entire set of data for that row for that year. Let's show the year. That was the year 1895. So I select it, right click, notice my cursor. My cursor, the right pointing arrow, tells me that I can now select the entire row. So I'm going to right click and delete the entire row. Notice what happened to the first outlier in the chart. I now only have 2 spikes. Let's go back to the column R and the meteorological annual. And here's it scanning down. I see another 999. I'm just doing this by hand, but I also know that there are only 3 of them. So that's in row 11. When I selected the 999, of course, my row is highlighted. My cursor changes. I'm looking for it to be a right-facing arrow. So now I can select the entire row by clicking, right-click, and then I can delete. Down to 1 outlier. And here it is. That's in row 14. Let's slide back. Select row 14, right-click, delete it. Now I've removed all of the outliers, and I have a chart that looks like it's doing some variations, but it's still not quite looking like what we saw on the website. Let's go back to the website. Here we have some large rises and large falls. And the problem, not really a problem, but it's just how the information is presented, and it's why it's not matching. Here the scale on the y-axis, the temperature scale goes from 10 to 13.5. Our scale by default with Excel goes from 0 to what it appears to be what Excel figures out as the largest, so 14. So 0 to 14. So let's change our y-axis scale so that we're closer to what the website is showing, just so that we can prove to ourselves that we've done everything correctly. Notice as I move my cursor around the chart that I get these tooltips that tell me here's the chart area. I move the cursor down near the bottom. Here's the horizontal axis. Here's the actual data for Met and I'm at the point for year 1937, or I'm at the point for year 1957. You want to take notice of these tooltips because they tell you where you are. These are mileposts. They are important mileposts when you're trying to select the axes. So as I move over here onto the axis, I want to notice how it just says chart area. I can be off by just a small amount. Chart area, moving the cursor a little bit, now I'm on the vertical axis. Very important difference here. We're not looking for the chart area, we're looking for the vertical axis. So you have to be very careful. Follow the tooltips here. Once you do that, you see the tooltip, select, I can double click, and now I have the ability to format the axis. We want to change the scale. Notice that Excel has set these up to be automatic. It looked at the data and said it ranged from 0 to 14. We want that to range from about 10. So we're going to change it to be a fixed, and let's also change it to go to 13.5, again just to match the website. And that's all we needed to do here. So let's close. And now our chart looks more interesting. We are able to zoom in, if you will, on the data. And we're seeing some of those rises and falls. Let's just double check. So we have a couple of low points at about 1918 and 1940. Let's see if that matched our website display. 1918, 1940. We have some peaks around 1920. And is that looking? That's exactly right. So we've been able to duplicate what the professionals did at the website by using Excel and analyzing the data, removing outliers. Now let's go further. Here we have the data. We see that it rises and falls. The temperatures are varying. Is it trending in any direction? Is it getting warmer? Is it getting cooler? Is it unchanged on average? So let's go to the chart tools, go to the layout, and select the trend line. Let's start with a linear trend line. It's the simplest to understand. Sometimes it's not the best one to use when we have a lot of varying data, but it is an easy one, so let's just add it. All right, there's the linear trend line. A little hard to see, so let's go ahead and see if we can select it. Notice the tooltip. Tells me I'm on trend line 1. Click. You can also see that there is a selection point at each end, so that tells me I'm on it. So let's go ahead and select that trend line by double-clicking. And let's change the line color to be a solid red. Let's change the line style to be a width much larger to emphasize what we're doing. So I changed the line style and the line color. And now we can see a little more clearly that actually over those years there is a trend downward, very slight downward trend. It's almost imperceptible, and it's almost flat actually, which tells me that there's not much change. Now there are other trend lines, as I said, so let's explore the other trend lines, because since we have a lot of varying data here, this straight line may not be the best estimate, may not be the best fit, is how we normally say it. So let's go back up to the trend line area, and we're going to go to the other trend line options, and you can try some of these other ones. The more mathematical you are, the more that you recognize that the line might look like an exponential, or it might look like something else. Let's just for now pick the polynomial. Let's not worry too much about the details of that. Just realize that a polynomial will rise and fall depending on the order. So let me slide this out of the way just a little bit, and I'm going to change the order. I'm going to increase it, and you can see that my trend line is changing over here as I increase the order, and I'm going to increase that order up to about 6. I think that's the maximum. Let's close this and look at it. And now we have a trend line which actually does better match how the data is varying. And this is actually probably what we would expect, that sometimes temperature data especially follows a rising and falling cycle. So temperature goes up and down and rises back up and falls again. And so we do see that that is the case here. So let's go ahead and change our chart title to represent that. Right now we just have a default chart title that's the title for column R. So here's our Johnstown data. And remember, we're trying to tell the story of the data, which is going to either be some conclusion, it's going to identify a problem, or it's going to identify a trend. So the Johnstown data seems to follow a cycle of rising and falling temps. All right, so your titles can be that simple, but they can't be as simple as just using the default column title. I want you to get into the habit of using the title to tell a story. So you have to do some simple analysis. Does not have to be complicated, but it should tell a story. Every title of every chart should tell a story. So there we have the Johnstown data. So what you will do now is go back to the website, the Goddard NASA website. You will pick your own spot in the world. I don't care where it is. Just try to make sure that the data is relatively complete over at least several decades. You will plot the data. You will add a trend line using Excel. So you're going to import it into Excel, plot it, get rid of any outliers, add a trend line, add a title, and that's the assignment.